Now we're going to move on to the next tool, which is called Colab. It's COLAB, Colab dot research.google.com, but just do a Google search on Google Colab and you will find it. And then once you open it, we've got about 15 minutes. I'm going to try to do this in about 5 minutes or so. And then I'll try to explain most of it as we're going through it. But please take the time to play with it and try it out for yourself. You know how to get a data set. Now, once you've gotten that data set, once you open Google Colab and you say new notebook, I know this looks, hopefully it's not that bad, but if this looks daunting, just kind of hang in there. The notebook is up here. You can just rename this. So I'm just going to say this. I'm just going to say experiment 1, and then the way this looks, you've got you can create a code block. You can create new code blocks. You can create text blocks. You can run it. We're going to look at the way this works. On the left-hand side, again, you can look at YouTube. You could look at, use your generative AI buddy to help you understand this. I'm just going to give you kind of the rushed case of this, the crash course in it. If I click on files, then I can upload a file from my computer. In this case, it's the mall customer. So that file that we looked at, I'm going to upload it. I'm just going to click OK. So that file now is available in Google Colab for this. The way the interface is split is that you've got kind of an inspector on the left-hand side that you can open and collapse, just like ChatGPT and everything else. And then you've got the place where you can actually write code. And what we're going to do is I'm going to look at, and I'll try to explain this as best as I can. I'm going to try to explain this as best as possible within the time frame that we have. So the first block, and again, in this case, I don't want you to, don't be overwhelmed by this. As the code is going to be available. Navi actually helped me generate this code anyway, but the code will be available. You can import, copy, and paste this code into your large language model, and you could tell it, walk me through this step by step. But what we're doing is we want to predict spending score from annual income from that data set that I showed you. We want to take those 200 records, create a linear regression model, so I can give it a new value to say I have a new customer with this much whatever annual income. Give me a prediction for their spending score. So I've just imported this. These are the different libraries that we need. Pandas is for table management. NumPy is for, I think, like numerical. Well, you can look it up. Matt, this is for plotting. Scikit-learn is an AI library that we're going to use linear regression from. And we're going to import the ability to train, test, do the splitting of the training set, the testing set, before we actually start using the model. The way this works, once you copy and place it, a block of code, you can click on play. And this is all hosted at Google, by the way. So there's no demand on your own personal computer. It doesn't matter what type of computer you're using, or, I think you could probably run it from your phone, because it's all cloud-based. So once I've done this, I can come in here and I can add another block of code. And we're going to do now is we're going to load the data set. So there's a couple of commands for this where I say read the CSV file, mall customers, the CSV, the one that I uploaded there. And this df.head, so I'm saying df is where I'm going to read that file. And I'm going to say, give me the head of that file. I just want to see the top of it. So when you run it, it actually shows, okay, you've got customer ID, gender, age, annual income, spending score. It's kind of giving you just the 5 records of that data set. Then the next block of code is going to be about, I'm going to select the features. I want to predict the spending score 1 to 100 using annual income. So I'm saying that the X values are going to be annual income. The Y values, the spending score, is going to be this from the table. So I'm saying from the table that you loaded, use this as X and this as Y, and now I give it the train test, the training and the testing, and how we want to split it by size. So I want to make it 20% split, 0.2. You can look up what random state means, just randomizing the way that the some of the like rows are selected, and then I can click run. There's nothing to output here other than that we're just training and testing. Doing the split on that, and then you come in and you can add another block of code where you could say, I want you to do linear regression, and then I want you to go ahead and create that model with the X and the Y that I've just split in the earlier step. I know we're running out of time. I think it was pretty ambitious to do this in an hour, but hey, we're going to learn. So this one is about, I'm going to provide this for you so that you could take the time to, you can dig into all of this code in more detail, but I'm just going to run through the rest of this because I want to leave at least 5 minutes for questions. I just want you to see the power of Google Colab. The intention here, again, is I don't want you to be confused or overwhelmed. You shouldn't be. A lot of this can be explained. You can go through it step by step, the different libraries and what they're doing. We want to understand the concept. The data set that we were looking at, the spending score and the annual income, is plotted like this. Do you see how it's all over the place? And this red line is the linear regression. This is the trained algorithm that says, okay, I'm going to predict, if you give me an annual income of this, I'm going to predict a spending score based on this linear line. Now, I want you to see how this is not a great example for linear regression, probably. It'll still do an okay job, but you could see all these outliers. The data is not like, usually you like to see a model that's kind of sloping upwards, and the data is actually scattered around that, like scattered up and below that line in that upwards trajectory, with a few outliers on the top and the bottom, but not like this. Nonetheless, this is still showing that you can take any data set and you can still train a model to be able to do prediction. And then the last block here in the code is going to say, we're going to actually run a prediction. So we want to predict a spending score, and we're going to give it, I think the example income is $60,000. And then when you run that, you get a prediction that says the spending score is 51.7. Okay, I know this was a lot to go through, but the last minute before we open it for questions through text is to say that we now understand, hopefully, the idea is you understand machine learning, you take labeled data, you use a training algorithm, and then you get a trained algorithm that you can start sending it new values and it will predict output. There are different types of machine learning. There's supervised, unsupervised, reinforcement. We focused on supervised, and within supervised, we looked at linear regression and a few others. We drilled down on linear regression to say this is where we're training it on data, which I've just shown you here, albeit it was very fast, but taking a data set that is available so you can you can go and explore different data sets that are available on the internet. And then you have tools available at your disposal for free, like Google Colab, to bring it in and actually start playing with these things. And don't be intimidated by the code, because the important thing is the idea. And we talked about this morning, critical thinking. That's the important skill. It's not how to code, because if you have the idea, you can go say, all right, I want to validate this. I'll go find the data set. There's Kaggle, Data.gov, blah, 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 wherever you find it. I'm going to bring that data set into Google Colab, and then I'm going to use my large language model. I'm going to tell what is my idea, and I'm going to let it generate the code for me to bring it into Google Colab, and then you can start actually running it, and you can actually start you can start doing the predictions yourself by feeding it to the large language model, take the code and paste it in here. But you can kind of drive, it's as if you have your own data scientist, AI researcher at your fingertips. The chat stopped at the top. If I have data set like this and it gives me the regression, I feel like I would have low confidence in the output. Yeah, probably. I mean, we're talking about that. You want to get more. You want to get more. You want. So the good thing about using this, it kind of brought out the importance of looking at data like pre-processing, data processing, and then selecting a model that is best suited for that data set. And it's your comment is good because you actually see that maybe linear regression is not the best for this. Maybe there's another, maybe it's forest or something else that would be better because, as I said, linear regression is more suited for like a data, almost like a data tunnel that looks like it's going up that way, and you draw a line across it to actually give you that prediction model. Oh, the underlying equation of the regression. So it is the logistics regression ends up being a y equals, and then it's taking all the x's and multiplying. And again, we're getting into the mathematics of this, basically multiplying a probability for what is the probability of that particular value plus the next x value multiplied by the probability of that value. And it just goes on and on and on for all 200 values. And you iterate on that over and over and over. So it's that y equals whatever. So when you give it the way that it predicts is by calculating that. So you end up with a formula that does that multiplication. And when you have a new value, you feed it and it runs through that multiplication to give you that prediction. Oh, can you get it out of the code? So if you look at the code, if you get towards the bottom, prediction of pd.draw frame, y prediction equals model.predict x test, the one above it, model.fit x train and y train. Why don't you play with it, Emily, and see? Ask your ChatGPT to see if you actually want the actual equation. But generally speaking, you don't care about the equation. You care about the function that you can call within sklearn and within like TensorFlow that does the prediction for you, because getting the formula itself isn't, it's not going to be, I don't think it's going to be of value versus calling the function that got trained and everything that's available through the library. All right, guys, thank you very much for participating. I appreciate it. And we'll see you in the next series. Thank you.